to the laws and principles that will make up the rest of the test. Okay, first of all, remember that an object at the surface, on top of the surface of a fluid, cannot float. And the reason why the object on top of the surface of the fluid cannot float is because the object has not displaced any fluid. So if the object has not displaced any fluid, the weight of the displaced fluid will equal to 0, which means the buoyant force will equal to 0, which means that the net force will be downwards because the weight acting on the object, which is downwards, is not being balanced by a buoyant force. And so, of course, this object will begin to sink. Now, as it begins to sink, immediately it will displace some fluid. And so if this represents the fluid displaced, notice this amount of displaced fluid has very little weight, which means the weight of this displaced fluid will represent a little buoyant force. And so immediately the buoyant force is evident here, but it's less than the weight. Yes, Allison. Okay, a fluid can either be a liquid or a gas. A fluid can be a liquid or a gas. So examples of fluid are milk, orange juice, water, salt water, air. All of those will be considered fluids. Okay, so as you see, students, yes, Fargo.
When you say air, do you mean like everything that makes up the air that we breathe, or oxygen?
Air, the mixture. Okay, very good. All right, Mr. Fahelain, you have a question? Okay. Yes, Cabrari.
Can other gases act as fluids other than air mixture?
Any liquid or any gas is a fluid. Fargo?
So if you combine air with any other, I guess, mixture, or gaseous mixture in itself is a fluid when you combine it?
Any liquid or any gas is a fluid. All right. Alfonso, have a seat. Okay. Now, so the net force is still downwards, and so what's going to happen, students?
It will sink downwards.
It will sink some more, but notice it sinks some more. As it sinks some more, it displaces more fluid, doesn't it?
Yes.
And so the weight of this displaced fluid is greater, which means the buoyant force is greater, which means now the net force is a little bit smaller, closer to 0, but still not 0. And so it'll sink some more. And so students, you see that as the object sinks into the water, the buoyant force increases. As the object sinks into the water, the buoyant force increases. Eventually, the buoyant force will equal the weight. Now, here's where it gets confusing. At the moment the buoyant force equals the weight, what happens?
The object floats.
You would think that the object floats.
It actually stabilizes its position in the fluid, or it'll pop up.
That's incorrect. Okay? Here's what happens, Beyonce. What happens is, once the buoyant force equals the weight of the object, what happens to the net force?
It's 0.
Very good, Julio.
So
The net force is 0. So if the net force is 0,
it will sink a little more.
yes.
It will continue to sink down at its current velocity because there's no force accelerating it.
Very good, Geraldo. Okay. So once the weight reaches the buoyant force, now the net force is 0. And so with that net force being 0, you would think that the object will stop sinking and float right there, but the object is in motion, And so it's going to stay in motion. So as it stays in motion, it displaces even more fluid. The buoyant force gets even greater. At this point, class, the buoyant force is actually greater than the weight of the object. And now the net force is upwards, which means what?
The object floats. It starts to rise.
It doesn't pop up.
It rises until they're equal, and then floats.
No. Now the net force is upwards. Remember, if an object is moving downwards and the net force is in the opposite direction of the motion, it's going to slow it down. So now the buoyant force is going to slow it down. So as it continues to sink, it actually is slowing down until the buoyant force is great enough and acts long enough to stop it. But notice, once the object is stopped, still there's an imbalance of force, isn't there? So what will happen at that moment?
It will rise up.
It'll rise up. And so, in other words, if you want to know the true science behind an object, solid object submerged in water, it will do this. Watch this. Does that look familiar?
Yes, sir.
So it will go down and up, and it will bob and bob and bob until it reaches an equilibrium. That's when it floats. Yes, Frederico. Yes, net force is 0 when W and B are equal. Correct. All right. Now, so any questions about Archimedes Principle? Yes, Alfonso.
You said that when W equals V, then it floats, which is what you put in the formula that's in the bottom there. So how come you said that the velocity will continue to sink when you said that when the net force equals 0? Because when the buoyant force and the weight of the object is the same, isn't the net force 0?
The net force will be 0, but remember Newton's first law: an object in motion will remain in motion. So at the moment where the buoyant force equals the weight of the object, at that moment, that's when the net force is 0, which means that if the object was at rest, it would have stayed at rest. But since the object was in motion, it will stay in motion, and that will cause the bobbing effect. Okay? All right. That concludes our wrap-up of Archimedes' Principle.